Heat is the energy transferred between a system and its surrounding as a result of a temperature difference. When the system has temperature different from the surrounding, we will have exchange of heat between the system and the surrounding. And the heat flows from hot to cold. What are the units of the heat? We use calorie, which is the amount of energy or the amount of heat required to raise 1 gram of water by 1 degree. This is the definition of calorie. We use now the modern definition, we use the joule. So 1 calorie equal 4.184 joule, and we can also use the kilocalorie. So all conversion of units are given in the exercise. Only you have to remember that the unit of the energy or the heat is calorie or joule. When a system absorbs heat, it absorbs heat from the surrounding, so its temperature will increase. And the increase of the temperature of a system is directly proportional to amount of heat absorbed. Suppose, for example, I am the system and the heater is the surrounding. When I absorb heat from the surrounding, my temperature or the temperature around the system will increase. As the heater gives more and more energy, that means the temperature of the system, my temperature or the temperature around the system will increase. So the energy absorbed affect the energy absorbed by a system from the surrounding affect the temperature of the system. As the energy absorbed increase, the temperature of the system will increase. We pass to the most important definition. What is the heat capacity? By definition, the heat capacity of a system is the energy required to increase the temperature of a certain amount of this material by 1 degree Celsius. I have, for example, a piece of metal of known amount, and I want to calculate the heat capacity of this substance. I bring a thermometer to measure the initial temperature of this material. Suppose it's equal to 25 degrees. I put this material on heater, and I measure the increase of the temperature. We said before, as the system absorbs energy from the surrounding, its temperature will increase. So I put the metal on heater, the temperature of metal will increase. It passed, for example, from 25 to 26. So the temperature of this material increased by 1 degree. Now I ask, what is the quantity of energy that is released from the heater to the metal in order to pass the temperature of this metal from 25 to 26 degrees? This quantity of energy absorbed is called the heat capacity of the metal. If you want to calculate your heat capacity, you get energy from outside and you increase your temperature by 1 degree. What is the energy absorbed in order to increase my temperature by 1 degree? This is my heat capacity. So the heat capacity is the quantity of heat required to raise the temperature of certain amount of material by 1 degree. The specific heat capacity is different from the heat capacity. The specific heat capacity is the amount of heat or energy required, so absorbed, to raise the temperature not of a certain mass of material, to raise the temperature of 1 gram of a substance by 1 degree. If I want to calculate my heat capacity, I increase my temperature by 1 degree. The energy absorbed to increase my temperature by 1 degree, this is my heat capacity. The specific heat capacity, I will consider 1 gram of substance. So I took 1 gram of this substance, I increase its temperature by 1 degree. This is the specific heat capacity of this substance. Sure, we have relation between the heat capacity and the specific heat capacity. The heat capacity is equal to the mass of the substance times the specific heat capacity. So heat capacity equal mass given times the specific heat capacity, which is per 1 gram of this substance. So the specific heat capacity is noted C or CS, specific capacity, and the units are joule per gram per degree. The molar heat capacity is the amount of heat energy required, so absorbed, to increase the temperature of 1 mole of substance by 1 degree. In the specific heat capacity of 1 gram of molar heat capacity per 1 mole, and the notation is C, only C and not CS, and the units are G, joule per mole per degree. So what is my heat capacity? Okay, the weight is 90 kilogram. I increase my temperature by 1 degree, and my amount is 90 kilogram. Okay, so the energy absorbed to increase the temperature of 90 kilogram by 1 degree, this is my heat capacity. What is the specific heat capacity? I take 1 gram of my substance and I increase the temperature by 1 degree. This is my specific heat capacity. What is the molar heat capacity? I consider 1 mole of my substance and I increase the temperature by 1 degree. The energy absorbed from the surrounding to increase the temperature by 1 degree per 1 mole of substance, this is the molar heat capacity. The heat capacity and the specific heat capacity are related. Heat capacity is equal to the mass to amount of the material by times the specific heat capacity. And if the heat capacity is defined according to the number of moles, also we can say that the heat capacity with respect to moles is equal to the number of mole times the molar heat capacity. So C given as amount per amount is equal to M, which is the mass, times CS. If the heat capacity is defined to the number of moles, I can say the heat capacity is equal to the number of moles of this substance times the molar heat capacity of this substance, which is per 1 mole. So what is the energy absorbed or released to increase the temperature of a substance? Suppose I return to the example of the metallic piece. I put this metallic piece on heater. So the temperature, so this metallic piece will absorb energy from the heater and the temperature of the substance will increase. The increase of the temperature of the substance depends on the quantity absorbed. The quantity absorbed by the system is Q, and the variation of the temperature is dT. So as you observed, the quantity of energy absorbed when heating a system depends on the variation of the temperature. If the metallic piece passes from 25 to 30, it will absorb a certain amount Q. If it passes from 25 to 50, it will absorb another value of Q. So Q is directly proportional to the temperature. This is factor 1. Also, the energy absorbed by the system from the surrounding depends on the nature of the system. Depends on the nature of the system. And the property that defines the nature of a system is the heat capacity of a system. My heat capacity is different from the heat capacity of another student. So also Q is directly proportional to the nature of the system. So Q is directly proportional to the heat capacity. Also, the quantity of energy received from surrounding to the system depends on the mass or on the amount of the system. If I want to heat 1 gram, the quantity of heat needed to increase the temperature of 1 gram is different if the mass is equal to 10 gram. So as a conclusion, the Q, which is the exchange between the system and the surrounding or surrounding to system, depends on the amount M or N, depends on the heat capacity C, and depends on the temperature T and T. So dQ equal, if the heat capacity is given according to the mass, I put M. And if the heat capacity is described according to the number of moles, I put N. So dQ equal mCS dt, or dQ equal nC dt. Which formula should be used? It depends on the type of the exercise. If the exercise he described the amount as mass, I have to use MCS. And if he used number of moles, I have to use N molar heat capacity. So dQ equal MCS dt, or dQ equal NC dt. Now I do the integration. The variation of dQ from state 1 to state 2, or from the initial state before heating to the final state after heating, equal integral MCS dt. Or if I'm working on the number of moles, I can write integral of dQ from initial to final equal integral of NC dt from initial to final. Now we have two cases. M and N are constant because this is amount given. So we have two examples. C depends on the temperature, or C is independent of the temperature. First case, if C is independent of temperature, so this relation will be transformed to Q equal M constant outside the integral, CS constant outside the integral, so it's equal MC integral of dt, integral from dt from 1 to 2, so Q equal MCS delta T, integral of x dx, integral of dx equal x. Okay, so dq integral MC dt, the formula is Q equal MCS delta T, or the formula equal NC delta T. This formula is for a physical transformation where the heat capacity is independent of the temperature. Pay attention. If C depends on the temperature, you have to solve the integral C dt. Delta T is equal T final minus T initial, and delta T, the temperature is described in degree Celsius or degree Kelvin. So delta T in degree or in Kelvin, this is the same, because if T degree minus T degree, you transform it to Kelvin, you add 273 and you remove 273, so delta T is the same. Delta T is described in Kelvin or degree, this is the same value. The second case, if C depends on T. So C is a function of the temperature. For example, suppose C equal A plus BT plus CT2. We apply the relation dq equal NC dT implies integral of dq from 1 to 2. So we obtain Q equal integral from 1 to 2 NC dt. N is constant. We put it outside the integral, but C is not constant, so you have to put the function of C to the temperature, and we solve this integral from 1 to 2 A plus BT plus CT2 dt. So equal N, the integral of A dt plus the integral of BT dt plus CT2 dt. We solve each part of the integral and we obtain integral of x dx is x. Integral of bx is bx2 divided by 2. Integral of CT2 is equal minus 1 over t. So you solve the integral, each part of the integral as separated. As a conclusion, as a summary of the heat capacity, the heat capacity is an identity of the substance. Each substance has a known heat capacity. What is the heat capacity? The heat capacity, you have a certain amount of this substance, you want to increase its temperature by 1 degree. The energy absorbed from the surrounding to increase the temperature of this amount M or of this amount N by 1 degree is the heat capacity of the substance. The specific heat capacity is the amount of energy required to increase the temperature by 1 degree for 1 gram of this substance. This is the specific heat capacity. And the molar heat capacity, you take 1 mole of this substance, you increase the temperature by 1 degree, and the energy absorbed is the molar heat capacity. How to calculate the energy absorbed by a system to increase its temperature? We have 3 factors that affect Q. Pay attention, Q is the energy exchanged by the system and the surrounding. Is the energy absorbed by the system from the surrounding, or is the energy released from the surrounding to the system? Q depends on 3 factors. First, it depends on the amount, M or N. On the mass, if the exercise is described according to the mass, or in the number of moles if the exercise is described according to the number of moles. So Q depends on the amount. Q is directly proportional to the amount. As the amount of a substance increases, we need more energy to increase its temperature. So Q is directly proportional to the amount. Q depends on the nature of the substance we want to increase its temperature. So Q is directly proportional to C, which is the heat capacity, the specific heat capacity or the molar heat capacity. We use CS or C, it depends on the nature of the exercise. If the amount is given in mass, we use CS. If the amount is given in mole, we use C. The third factor is what is the temperature final? To increase the temperature from 25 to 30, we need a certain amount. We need a certain amount absorbed. If we want to increase the temperature from 25 to 50, necessarily the amount absorbed is different. So Q is directly proportional to the amount. It's directly proportional to the nature of the substance. It's directly proportional to the variation of the temperature. So dQ equal NC dt if we are working on the number of moles, or dQ equal MCS dt if we are working on the mass of the substance. Now we have two cases. M or N are constant. Amount given. We have two possibilities. C is independent of the temperature, or C depends on the temperature. Some substance have C independent of T, other substance have C dependent on the temperature. So what to do? If C is independent of the temperature, the formula is Q equal MC as delta T, and delta T equal T final minus T initial, or Q equal NC delta T, and delta T equal T final minus T initial. If C depends on the temperature, you cannot put C outside the integral. You have to put what is the relation between C and temperature. You put the function of the temperature, and you solve the complete integral of the function of the temperature Ft times dt. So you have to solve the integration. This is all about the heat capacity. The last slide of this part is the specific heat of common material. If we look to the elements, lead, gold, silver, copper, iron, aluminum, water, we observe water 4.18. So the water has high specific heat capacity. When the specific heat capacity increases, that means the substance absorbs a lot of heat without a large increase of its temperature. So water, for this reason, the large amount of water absorbing heat from air keeps the cool, did not change the temperature. Okay? So water can receive a large value of energy in order to increase its temperature by delta T. Lead can receive a certain amount of energy directly its temperature increased by delta T. So for this reason, we define the conductors of heat are material that have low heat capacity, and the insulator are material with high heat capacity. Since water has large specific heat capacity value, so water is insulator. Lead has a very low specific heat capacity, so lead is conductor of heat.